We know the values of 4 and -3 would make this left-hand side equal to 0. We can use these two values of x equals 4 and x equals -3 to create three separate intervals on a number line. These three intervals may contain the numbers that are solutions to our quadratic inequality. For example, all of the numbers to the left of -3 will either make this statement positive or negative. We can use a test point within this interval or a test value to find out. For example, I could use the value x equals -4 to determine whether or not this left side is positive or negative. We want this side to be greater than 0, so when I plug in -4, I would want this to be a positive number. If that's the case, then every number from -3 and to the left will make this statement positive, which means we include it in our solution set. So rewriting my original inequality here, I can plug in the value of -4 in for x. When we evaluate this, we'll get 8 is greater than 0. We know this statement is true, so we know all the values less than -3 are solutions to our original inequality. If you're in disbelief that all the other numbers in here work, then try plugging in -5 or something like -10 in for the value of x. You should wind up with a positive number on this side. Here, I've gone ahead and shown you another check for x equals -8. If we use this value in interval 1, we'll wind up with the statement 60 greater than 0. We know this is true, so again, this is part of our solution set. We don't need to test every value in interval 1, we only need to test one of them. You try testing interval 2 and interval 3. Pick one value for x in this region and in this region. Plug them into your original inequality and see if you come out with a true statement. If true, then that interval is part of the solution. If false, then that interval will not be part of our solution. Also, as a hint, think of an easy value to plug in that's between -3 and +4. What do you think is the easiest value to use in between these two numbers?